Morning, officer.
Morning.
Listen, I can explain why I was going 50 over in the school zone.
Actually, we got reports of someone driving impaired with their license plate. You got an explanation for that?
Yeah, that couldn't have been me. There must be a mistake.
You sure you haven't been drinking in the last few hours?
I'm not at all. This is just water.
Well then, could you go ahead and blow into this breathalyzer?
The breathalyzer.
Yeah?
Do you even know how that works?
How's that relevant in this
Well,
case?
here, let me just show you. So, the type of alcohol found in any alcoholic beverage is actually called ethyl alcohol, also known as ethanol. And this ethanol can be found circulating your bloodstream. Now, since ethanol is highly volatile, meaning it evaporates readily, and since your body's warm, the ethanol in your bloodstream can actually evaporate and enter the alveoli in your lungs. What this means is that when you exhale or when you breathe out, you actually breathe out lots and lots of tiny ethanol particles. So when you breathe into a breathalyzer, the breathalyzer is actually able to sample that breath for ethanol using gas phase IR spectroscopy. And it's able to use this technique in order to determine the amount of alcohol in your blood.
IR? What's this IR thing anyways? And how's that supposed to detect ethanol?
Well, I'm glad you asked. Let's look at a molecule of ethanol. An ethanol molecule has many different bonds. There are CH bonds, there's a CO bond, there's an OH bond, and each of these bonds is actually vibrating, and so it has vibrational energy. Now, as an example, let's just look closer at OH. If we assume that the bond between the oxygen and the hydrogen is a spring, and that spring actually obeys Hooke's law, what we can do is that we can use quantum mechanics to solve for the vibrational energy of this molecule, or of any molecule. And that's the equation we get, and this equation tells us something very interesting. It tells us that the vibrational energy of any molecule is actually quantized, meaning that the molecule can't vibrate at any energy it wants, it can only vibrate at very specific, distinct energy levels. And in order to go from one energy level to the next energy level, it actually has to absorb a very specific amount of energy. This is very important because it means if we shine a light through the molecule can actually absorb energy from that light to go from one energy state to the next. And the amount of energy it absorbs from that light is dependent on two very important variables. K, which explains how stiff the bond is between the two molecules, and mu, which explains the reduced mass of the two molecules. And if you actually decrease K, or if you increase the reduced mass, the energy gap decreases. And conversely, if you increase K or decrease the reduced mass, the energy gap actually increases.
Let me try to connect the dots here. So what you're trying to say is each bond has a different value for K and mu, and since K and mu influence directly on the energy gap between the energy levels, it means that each bond actually absorbs a different amount of energy to go from one energy state to another. And since the energy is related to the wavelength of light, that means that each bond actually absorbs a very specific wavelength of light. So if you have a molecule with various types of bonds, each bond will absorb a very specific wavelength of light, which gives the entire molecule a unique IR spectra fingerprint that can be used to detect it using an IR spectrometer. So what happens in the breathalyzer is that the light source shoots light through the gas chamber, which has the ethanol, and then the detector can measure what wavelengths of light was absorbed, and based on this information, the machine is programmed to detect the very unique molecular fingerprint produced by the presence of ethanol, and after a few calculations using the amount of ethanol detected in the gas chamber, the breathalyzer can give out a reading for the concentration of ethanol found in your bloodstream.
That's it. You got it, man.
Oh, that makes perfect sense. You have a great day, sir.
Thank you, you as well.
Wait a minute. I just realized I forgot to test you.